So Module 7 is on collecting data. I'm not going to go through every single part of this because you will be bored out of your mind, but for the most part, there's a lot of vocab. So make sure you read through and understand what it's asking you to do. For the most part, it is just a lot of vocab. So first thing, a population is the group that they're collecting data on. So it's who they're basically trying to describe in that study. So if we were looking at this question, it says, if we wish to study the amount of money spent on textbooks by first-year college students, our intended population may be any of the following. So they can either be first-year community college students, first-year students in a public Utah college, or first-year students in colleges and universities in Utah, any of them, or first-year students at the colleges and universities in the U.S. It doesn't matter unless it specifies, but we could use any of those groups to describe our population. Sometimes the intended population is referred to as the target population. A parameter is just a value that's given, or that's calculated, I should say, using the population data. So that can either be the average, a percentage, or just a number. Parameters are seldom used because we usually can't survey an entire population. So parameters, the idea is that it needs to represent the entire population. And so if we're talking about the entire population, parameters are not as accurate. We usually just look at a sample or a portion of a population and base our generalization off of that. So a census is just a survey of an entire population. It's usually given, for us, we do a US Census every 10 years, and we just finished that this year. And that's one example of a census. Another example of a census would just be a store manager wants to know the average number of hours her employees worked in the last month. And so she just asks or figures that out by looking at their time card. A sample is a smaller subset of the entire population, which is what we talked about. So an example would be if they're looking at how many fish are in Strawberry Reservoir, they catch 200 fish and measure them. They wanted to know what the average length is. And so this sample is going to be the 200 fish that they caught. And then the population is all trout in the lake. Okay, so all trout and strawberry. That's kind of the difference between the sample. The sample is the 200 fish that they caught. And they want that sample to represent the general population of all of the fish. A statistic is a value that they used based off of a sample. So a parameter is based off an entire population. A statistic is based off of a sample. That's the difference between those two. So as we look at example 1, it talks about the city of Raleigh, and there's 9,500 voters. There's 2 candidates for city council, Brown and Felice. They talk about the day before the election, they do a telephone poll of 350 randomly selected registered voters, and 112 said they'd vote for Brown, and 207 said they vote for Felice, and it says 31 were undecided. So when they talk about the population, the survey is interested in, it's all the voters, okay? So all voters in Raleigh. If they talk about the size of the population, there's 9,500 registered voters in Raleigh. So when you look at the population that's represented by this survey, we're looking at our registered voters. So that means at a certain or a given time. So it says describe the sample of the survey. The sample is the 350 that they decide to call. And then it says give the sample statistic for the proportion of voters surveyed who said they would vote for Brown. So out of the 350, there was 112 out of 350. So if we divide it, we get 0.32, or 32% of the voters would vote for Brown. And it says based on the sample, how many of the 9,500 voters would vote. So we would go 0.32 times how many voters there are, which are 9,500. When we multiply, we're getting about 3,000 voters would vote for Brown. And that's kind of the general idea of what we're going to do in this section. Example 2 and example 3, same idea. They're just looking at having you describe what the population and what the survey is representing, or what a parameter statistic. So like if I was looking at this one, example 2, because it's talking about a portion, so they're saying there was 500 randomly selected shoppers, not every shopper that went into the mall, but it randomly selected. So that's a sample. And so because it's a sample, then it's a statistic. And then same idea. This is shoppers at, this would be the shoppers at Southtown. And this is all, I should say Southtown. Where this one would just be all Salt Lake City citizens that are intending to vote. So that's the population represented by this survey. Or you could actually do, this is who it's intending to represent. But really, who it is representing is the mall shoppers. So notice how those two things are different. If I'm just talking about, they're saying the people that are at that mall represents all of Salt Lake City voters, but really is only representing the people that would shop at the mall. As we look at the next page, it talks about quantitative and categorical data. Categorical is going to look at, or qualitative is looking at categories. So that would be like the color of a car or something like that, where a quantitative is a number. So this is a numerical in nature. So 3 or 4 or 5, where this could be where qualitative might be a color or a pet or something like that. So when you look at example 4, they talk about what category it would fall into. So because it's an age, it's quantitative. Because it's asking for a gender, it's qualitative or categorical. So we'll do quantitative as Q, categorical as C. If we talk about the color of your car, that's categorical. If we talk about the height, that's quantitative. How many pets, that's a number, so it's quantitative. And your annual income is money, so it's quantitative, it's a number. When we look at different sampling methods, there are a few. So simple random sample just means that you randomly take a portion. It's not a huge thing. We just pick a group and we choose to ask them a question or survey them. Stratified sampling is where you're wanting to make sure that you pick a certain amount of each category. So they talk about how population is divided into a number of subgroups. And from each subgroup, they take a random sample. So the example that they give is, suppose a particular state, the data indicates that the electorate was comprised of 39% Democrats, 37% Republicans, and 24% independents. So it says in the sample of 1,000 people, they would expect to get what? And so basically, you're going to go 0.39 of 1,000. So you would be expected to get 390 Democrats. If you did 0.37 of 1,000, then you're expected to have 370 Republicans. And if you had 0.24 independents, then you would be expected to have 240 independent voters. So that's kind of how they take the general population and they divide it into subgroups. And then from that subgroup, they're taking a statistic from there. Systematic sampling is where they're just picking every nth member. So like if I was going to go, like every third person is going to stand up and introduce themselves. That would be systematic sampling because I'm taking every so many people in a population. Quota sampling is kind of like stratified sampling, but they're collecting in each subgroup. They know how many people they need to ask in each subgroup, I guess is the best way to say that. So if they call people at random, but once they've met their quota of 390 Democrats, then they're done. So if the next person is a Democrat, they don't ask them the survey. They would move on to Republicans if that's what if they needed so many of each, then they just keep moving on until they get the number that they want of each subgroup. Convenient sampling or voluntary response sampling is more like they stand on a corner and they just ask the first 100 people they see. Or another example is at the restaurant where they give you the survey at the bottom. It's voluntary, so you don't have to fill out that survey about how, like, what your experience was, but you choose if you're going to do that. Or Walmart, when they do the same thing, you can do a little survey. And then cluster sampling is a way for you to take a population that's divided into subgroups, and then from there set in a group of subgroups from that. So if it says if a college wanted to survey students, since students are already divided into classes like sophomores, juniors, seniors, then they would take 10 sophomores, 10 juniors, 10 seniors, and ask them the questions or do the survey based off of that. So example 5 talks about what the sampling method is. So you should probably pause your video for a minute, go through, see if you can figure out which type of sampling it is, and then come back and see if you're correct. So example 5, the first one is going to be systematic because they picked every 10th person. So that's the key there. The next one is going to be simple random sampling because they just randomly pick 20 cards. The next one is stratified because they took 50 people from each gender, which the gender is already putting it into subgroups. This is convenience because they just asked 20 people that are your friends, so you don't have to go out of your way to do that. And then the last one is cluster. So a sample is divided by in 5 groups, and then you ask 2 of the 5 people what kind of ice cream they like, and so that would be cluster sampling. So that would be based off of our sampling. With sampling, there's biases that are built in. So a bias just means that it doesn't give you an equal likelihood of an answer being given. So sampling bias would just be when the sample is not representative of the population. So if I go to Walmart, I might have a different clientele than if I go to, let's say, the mall. And so what the questions that I ask them, they might have different answers based off of the type or the socioeconomic area that they're at. Voluntary response would occurs when if you ask people to volunteer to give you, let's say you ask them to say if they enjoyed the restaurant or not. If they had a good experience, they might not necessarily respond, but if they had a bad experience, they will. So when you have voluntary response bias, it's because you either have either end, either somebody that really liked it or really hated it. You usually don't have the middle ground people that are responding. Self-interest study, that there's a bias there if the person who's creating or surveying the people are picking people so that they get the response that they want. A response bias is if the responder gives an inaccurate response for whatever reason, they're in a hurry. They don't really want to be bothered. They know why you're asking them and trying to make you happy or not happy. Loaded question bias is just when the question, the way it's worded, makes you respond a certain way. And then there's a non-response bias where people just refuse to participate in the study, and so it's hard to validate the outcome. So same idea here. If you pause your video for just a minute, read through them, figure out which bias it is, and then come back and see if you're right. So A is going to be a voluntary response bias because depending on who you ask, like if you're asking, let's say, an older person, then they might be annoyed by the rock music. But if you're asking a younger person, then they might like it. And so it's based off of who's willing to respond to you. B, it says a survey call people from the phone book and ask them to answer a long series of questions. That's like a non-response bias, because if it was me, I wouldn't want to answer a long series of questions. And most of the time, if I can't tell who it's from, I just don't even answer my phone. C is going to be a self-interest. Well, that's supposed to say S. So this would be a self-interest bias, because depending on who you ask, if you're trying to figure out if they're going to support a downtown renovation project and you ask people in downtown, then of course they're going to say yes. But if you're asking people that aren't downtown, then maybe you're not going to get the same response. And so they're specifically targeting the downtown businesses. And so because these are the same, they both have the same interest, that's a self-interest bias. D is going to be, this is kind of like a perceived, I don't know if that was on there. Yeah, it is. Perceived lack of anonymity. If your boss asks you, or the boss of the company asks an employee to anonymously report concerns, this is supposed to say work, they might think that it's not going to be anonymous, and so they might not respond the way you want them to, or the way you would expect them to, because they are trying to respond to make the boss happy. And then this is a response bias, because they asked to report the actual income and the income they reported to the IRS. Those are not necessarily the same, and so they might change their answer to make sure that it all works out nice. And then the last one is a self-interest, because they're asking families who are spending time in the park if they should, but they're doing it at the park. And so because those are the same place, that's a self-interest issue. All right, so observational studies and experiments. An observational study is a study based on observations, where an experiment is based off of the effects of treatment. So observation might be like the weather. So if you calculate, or either calculated or took the temperature, or logged the temperature outside for a month, and then the following year looked at what the temperature was for the month, and you could, based off your observation, figure out in general what the average temperature is going to be. Where an experiment is more looking at, if I give you this type of treatment, how does that affect how you feel? So when you look at example 7, they're just talking about some different ideas. If it's a study or an experiment, same idea, you can pause it and then come back and see if you did it right. The temperature on randomly selected days, that's an observation. A group of students who are told to listen to music while taking a test, that's an experiment, because they want to see how the music affects their test scores. They talk about, this one's talking about a woman walking out of the grocery store, what type of shampoo did they purchase? That's an observation because you're looking to see what they observed. And then D is saying 50 people with back pain sleep with tinfoil wrapped around their head, and 50 people with back pain sleep without tinfoil, and they want to see how if it reduces back pain. And so that's an experiment because one has a treatment and the other one does not. Confounding means that sometimes you can see that one, like you have a reaction, but if there's two potential variables that could have caused that outcome, then because you can't tell which one it was, that's what it means to be confounding. So an example of that might be this, where it talks about in a middle school, they find that the students aren't scoring very well on their state math test, and so they decide to run an experiment. And so they see if an alternate curriculum would improve scores. So to run the test, they hire a math specialist to come in and teach a class using the new curriculum. So then to their delight, the improvement in the test scores, so they see the test scores go up, but the problem is there's two things that they did. Not only did they change the curriculum, so they changed the curriculum, but they also hired a math specialist. So because they did two things, they can't tell if it was because the curriculum change was good or if it was because the math specialist was good, or if it was a combination of the two, but they can't tell because there's two things going on. So if you look at the next example, see if you can figure out what the two confounding variables are. So same idea here. It talks about they're studying a weight loss pill, and it tells you that the statement, it says they should also do diet and exercise because there's diet and exercise and they're taking a medication, you can't tell which one of those is the reason for the people to lose weight. And so again, that causes a confounding issue because you've got two things that could be making it so the person could lose weight. So when you do an experiment, there can be a control group and a treatment group. And so the control group does not get the medicine, the treatment group does. And so, or I should say, it doesn't have to be a medicine, it just has to be some type of treatment. So when you look at this example, it talks about they've got a 2-day prep course that they want high school students to try and see if it improves their score. So half of the group gets to use the prep course and the other half does not. And then afterwards, they're both given the ACT and they look to see who did better. So the control group is the group that didn't get the prep course, and the treatment group is the group that did receive the prep class.